Hello friends, I welcome you all in this video. Today we are going to understand Python data structure. So far in our journey, we understand basics of Python, we understand variables, data types, strings in detail, conditional operators, iterative statements, range functions, how to take input from the users, arithmetic operators, conditional statements, membership operators, and a lot of things. So if you are just joining this video, make sure you go to the entire playlist. Now in this video, we are going to start with Python data structure. As I discussed in the previous lecture, right? Say why we need data structure. So far we understand how to store single value in a variable. But what if you want to store number of items? You want to store multiple values in a variable, and here data structure comes to the picture. Let me share my screen and start the session. I hope my screen is visible. Yes. So we are going to discuss Python data structure. In Python, we have four major data structures: list, tuple, set, and dictionary. So what I'm going to do, I'm going to create four videos, one for list, one for tuple, one for set, and one for dictionary. Make sure you go through all of them. Let's start with list here in this video. So what is data structure, friends? They are like a container which holds collection of data. It is fundamental of any programming language, but believe me, in Python, when you work with data structure, it is very simple in comparison of other languages. For example, if you understand data structure in C# or in Java, right? It's bit complex in comparison of Python. Simple for you. So let's start it. We have this four data structure: list, tuple, set, and dictionary. In this video, we are going to understand list. What is list? Is a collection of items. Now understand, friends. Before I go for the next slide, to make it pretty simple for you, in this particular topic, I'm going to use some different approach. So let me open my OneNote. You can see, yeah, OneNote is here, and I'm going to add a new page. I'm going to write Python data structure. We have slides, that is fine, but I feel this will give you instant kick on what is data structure and how it works. So the first we are going to understand is list. What is list, friends? So list is a collection of mutable items. Mutable items means what? Mutable item means once the list is initialized, we can add, update, and delete elements at any time. That means we can update the list. We can update the list elements. In Python, to create the list, we use square bracket. Again, list is like list of employees, list of product, list of categories, list of genres, lots of things are there, right? Each item, we can write each item in the list is comma separated, and each item in the list is comma separated, and each item in the list has an index starting with 0. So it's a collection of elements. Each element is separated by comma. Index is starting with 0. And as it is an index, items are always in the order. So every time you run the list, you get the items in the same order. Order of the items should be always maintained. Second thing we can do, we can perform various operations. We can have like list indexing, the way we had string indexing. We have list slicing, the way we had list slicing, the way we had string slicing, right? So I can create list. So my variable name is say employees, and then in the square bracket, I provide Kunal, Nelson, Prashant. So this is what list of employees. I can have fruits, apples, mangoes, banana. Say list is different from an array. In basic Python, we do not have concept of array. If you want to work with array, we use NumPy library. Again, why here we do not have an array and what purpose array serves, when should we can go for array, that we will see when we work with NumPy. One more thing here, list can hold item of any type. So we can have list of integers, we can have list of strings, we can have heterogeneous list. It's possible over there. When we go for array, so we have to define that array type is like array of numbers, array of strings. But we cannot have an array where we have numbers and strings together. I'm talking about C#, Java, C++, right? But here in the list, it's a heterogeneous list, right? It can have items of any type. What we are going to do, we are going to perform the demo. Before we perform the demo, let's quickly go through the various methods of the list. So we discuss what is list. We have 4 type of operations possible on the list: add, update, get, and delete. Add is to adding the new list elements. Update is modifying the list elements. Get is retrieve the element based on index. Now we can retrieve the elements based on index. We can retrieve the elements based on value. Both is possible. I'll show you. Both are possible. I'll show you. And delete. Delete is used to delete the list element. Again, to add the list element, we have various methods. So for the add operations, we have methods like append, insert, and extend. What is append method? As the name suggests, append. It adds the item at the end of the list. Append method adds the item at the end of the list. What is insert? Insert method add item at the specific index. And extend, with the help of extend method, we can populate list element by another list, tuple, set, or dictionary. So we can add multiple elements from another list or another tuple or another set to my original list. This is the add operations. Add specific methods, add operation specific methods. We have update operation. Update operation is used to change the value of a specific element in the list, the value of specific item in the list. And for that, what we can do, we have to grab the list element. We can grab it by the index, and then we provide the new value. We grab the list element using index, we provide the new value. Again, we have multiple options that we'll see. We have get operation and we have get specific methods. Here as I mentioned, we get the list element based on index and based on values both. We'll show you. And delete. To delete the list elements, we have various methods. Remove method, it removes specific item from the list based on value. Pop, it deletes the list element, it deletes the last element from the list. If we don't know which one is the last element, we can use the pop method. We have del keyword, it deletes the list completely, and clear, empty the entire list. So these are the various list specific operations and methods we have described, but now it's a demo time. We are going to perform demo, and believe me, you are going to learn a lot in this demo. It's very useful. So I'm going to create the new file 8 Python data structure list. Okay, so let me start with creating an empty list. So I create one list, say my empty list. It is just the variable name. If I provide values in the double quotes, it would be string. This is integer, but to create the list, we use square bracket, and it's an empty list because we have nothing in the square bracket. Now I check print type of variable my empty list. When I print it, you can see it is of type what? Class list. It is a list. Then even I can check print length. So let me write length of the list. Len and when I see length of the list is 0. So very simple, we just create this, we just put the square bracket and the variable is of type list. List type is injected to that variable at the runtime, because we know Python is what? Is a dynamically typed language. Now let me create one more list. So I create list of ints. Is a list of integers for sure. I create one heterogeneous list. List of misc is a miscellaneous, and I just provide the value. Say this is the decimal value. This is the integer. This is my Python, not yours. It is my Python. So we have this list here. It's a heterogeneous list. Again, I can check print length of the list of ints. List is len and if I run it, we just get to see 4. We have 4 items in the list. Same way, if I copy this line, I hope you are following with me, you are following me, you are writing the code with me. Put the comments if you are stuck somewhere. And we have list of misc. This is list of misc. And yes, we have 6 elements. This is 1, 2, 3, 4, 5, 6. So we have this 6 elements. Right now, what I'm going to do, I'm going to create a list from the range. You know, the range function, right? Range function is used to generate the sequence of numbers. With the help of range function, we can generate the sequence. We can perform operations on that sequence, like we did multiplication and square root numbers and all. But if I want to grab a particular element from the range, it's not possible because it's not having any index. I have to check something programmatically, but directly it's not possible. That's what I'm trying to say, right? So what we can do, best way is to convert it to the list. I can check for this item in range. If item dot lower equal to these, then you grab it and you can do something. But you cannot grab the element based on index from the range because it's not having index, right? So what we are going to do, we are going to create the range and we are going to convert it to the list. So here I create one variable, integer sequence. It is a range 1 to 11. So starting value is 1, stopping value is 11. It will take one item less than 11, so it would be 1 to 10. And now I am going to convert it to the list. So it will take the range from 1 to 10, convert it to the list. So each and every element would have an index. So here if I write 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and when we convert it to the list, we'll have index like this is at the 0th index, this is at the first index, and so on, because we convert it to the list. So now I print in sequence list. I am printing each and every element of the list here. Spelling mistake, typo. Yes, I'm getting it from 1 to 10. And now as it is converted to the list, it is having index. I can grab the element based on index. So what I'm going to write here is print and say the item at the index 3 is index 3 in the list sequence is, and what I write here, can you tell me list name and index 3. This is what the index. So this is at the 0th index, first index, second index, and third index. So I will get what? I will get 4. Yes, and the output is 4. Correct. We can also access the list element and we can modify, right? So what I do, let me write, say, accessing the list element using index and modifying it. So I write the list in sequence. I take the item at index 3. I know it is, the value is what? 4. And I change it to 111. And then if I print the list here, so you can see I get the list element, but this time item at index 3 is 111. Last time it was 4. That is now updated. So we access the list element and we modify it, right? Now we know we cannot perform arithmetic operations on the list directly. I mean, what you have to do is, you have two options. You go to the list, you grab the element based on index and perform your arithmetic operation. That is the first option. In second option, you use the for loop or while loop. You iterate through the list, you take your element and you perform the operation. But you cannot perform directly. What I am trying to say is, if I write like this, say print list of ints multiply by 3. So my intention is what? I want to multiply each element of the list by 3. But I cannot directly write this. If I write like this, you can see it's like a repetition. So all elements are printed 3 times. It is like a repetition. So it's like, it is what? It is repetition. What we can do? Two approaches. Again, two approaches as of now, because later on we have list comprehension. When you work with lambda functions, we have map, reduce, filter. We will see them. But right now, as of now, so far what we have discussed, we have only two approaches. The first approach is what? Access the list element by index. And second, use iterative statements. So if I write first approach, right, say accessing the list element by index and performing arithmetic operation. So I write the same way, print int sequence, take the item at index 2 and multiply by 3. You can see item at index 2 I take int sequence list. Let me take list of ints here because we are discussing that list. This is my list of ints. Item at index 2 is 5 and that we multiply by 3. Second approach, using iterative statements. So I write for item in list of ints, for item in list of ints, and I say print item multiply by 3. Here I am taking each and every item of the list and multiplying by 3. Right? But as of now, we cannot, we don't know the approach to directly modify the list element. We have, but that we'll discuss later on. We have list comprehension, map, method, filter, reduce, that we'll see later on. Right? Okay. Now we also have, this is a single dimension list, right? We also have 2-dimension list. So what I'm going to write now, I'm going to create one list. And I'm going to write, say this is the 2D list. Now in this 2D list, say I create one list, say my list. And here, this is the outer list, right? Okay, yes. So my list, this is the outer list. Now in this list, I'm going to create 3 elements. And each element is also of type list. So it is like my 2D list. So here I write 10 and 20, 30 and 40, A and B. This is my to-do list. So now if I print my list, it prints the entire list here. Now I say print my list and I want item at index 1. Can anyone tell me, friends, which item is at index 1? You can just put it in the comment box. Correct, Rajesh. It is 30 and 40 because this is my index 0, this is my index 1, and this item is at index 2. So when I print the item at index 1, it's going to print 30 and 40. Now let's go one step ahead, and I say go to print, go to my list, go to item at index 2 and print the item at index 1. Any guesses? Which item is at index 2, friends? This is at index 2. And again in index 2, I want item at index 1. So this is 0. And this is at index 1. That is B. So when I write it, my bad syntax. The syntax error. This is what B. We can also have list slicing that we'll see later on, right? So this is what we have 2-dimension list. Same way I can go for 3-dimension list also, right? You can try it by your own. You want me to do it? Okay, let's do it. Let's go for 3-dimension list. Give me a second. It is stuck here. Okay. Come on, man. Now we have 3D list. So again, I'm going to create one list, say 3D list. And this is the main list. In this list, I have 2 elements. First element is of type list. Second element is also of type list. So in the first element, I enter 1, 2, 3. But here, the 4th element itself is one more list. So 10, 20, and 30. While for second list here, I write A, B, C. So if I try to print the element here, okay, let me tell you, first of all, this is the list. This is the list. So this is at index 0. This is at index 1. Now in index 0, I have 1, 2, 3, and this is one more list. And everything is part of the outer list, 3 dimensions. So now if I try to print (3D) list, and I want to print item at index 0, then item at index 3, and then 1. Can you guess? Say item at index 0. That means I'm looking for this one. Then here item at index 3. So this is 0, 1, 2, and this is 3. Again in 3, I'm looking for item at index 1. This is 20. Yes. So output is 20. Correct? Now, say to delete the list element, we have two approaches. One is the del keyword, one is the remove method. The del keyword delete the list element based on index. Del keyword delete the list element based on index. Let's see it first. So here we are going to use del keyword, and I say print in sequence list. It will print the list. I print length of in sequence, and now I write del in sequence delete the element based on index 0. So it will delete the first element, and then again I print in sequence, and I print length of in sequence. So if you see here, this is my list. This is the length, 10 elements are there. We delete the element which is at index 0, that is one number. So that is deleted here. And now the new length is 9. So with the help of del keyword, what we did, we delete the list element based on index. Second is remove method. So with the help of remove method, we delete the list element based on values. So here we say delete the list element based on values. So I'm going to create the new list, say languages, and I write, say, Java, C#, React, and Python. Now, sorry. Now, here, first of all, I'm going to check the existence of the item in this list. And for that, we have to use membership operator. If you remember, we discussed in and not in. In and not in. Both are used to check the existence of the item in the collection. So what I'm going to write here is, I'm going to write if Python in this list. If Python is available in this list, then remove Python. It is case sensitive because here I'm having capital P in Python, so I'm writing capital P here. If I write lowercase p, it says it does not exist there. And then I'm just going to print the list again. Let me also print the list, the original list. So here we have Java, C#, React, and Python. Python exists in that list, so we have removed Python from here. Same way, I check if 6 not in the list. I'm directly creating the list here, 1, 2, 3, 5. 6 is not there, so I'm just going to print 6 is not the part of the list. So here we get to see, okay, here. So we get to see 6 is not the part of the list. Not a part of the list. Right? Okay. So here we see in and not in. So I can just put in the command membership operators in and not in. You would see, you would get all the code presentation deck from the description section as well as the pinned comment section of the video. Go to the pinned comment section of the video, you will get my GitHub URL where you can clone the presentation, you can clone the code also. But I strongly insist, take the code, but try to write the code by yourself. Don't copy paste. Right? You are getting a real hands-on learning experience. So perform it along with my video, right? Step by step. Okay. Now we have sort methods. We can sort the list elements, right? So here we have a sort method. It sorts the list elements. So I'm having the list numbers is equal to 1, 6, 8, 5, and 10. And let me print the numbers first. It will print the numbers. Let me write it like this. Numbers. Now I want to sort them. I want to sort them in the ascending order. So I write numbers.sort, which sorts the elements in the ascending order. After sorting, if I print the numbers, so if you see the original numbers are 1, 6, 8, 5, 10. After sorting, it is 1, 5, 6, 8, 10. We can write here sorted numbers in ascending orders. I can also sort the numbers in the reverse order. So what I'm going to write is sorting the numbers in the descending order. So for that we are going to write numbers.sort reverse is equal to true. And now if I print sorted numbers in descending orders, so here you can see it is 10, 8, 6, 5, 1. We just put reverse is equal to true, right? But problem with this approach is what, friends? It is changing my original list. Say this numbers is my original list. And when I apply the sort method, it's actually modifying this list. Because now I do not have, once I perform the sort method, I do not have original list available. It is sorted. Here it is sorted in reverse order. Then I do not have the original list available. So many of the times what you want, you do not want to disturb, you do not want to touch the original list. You want original list as it is, but you want the new list which is in sorted order. So that time we have a function. Yes, we have a function called sorted. It returns the new sorted list. It does not touch the original list. I can show you. Again, let me create a new list. Say new list of numbers is equal to 10, 20, 30, and 40. And now I write new sorted list of numbers is equal to sorted function, and I write new list of numbers. So sorted function returns a new sorted list. So if I print here, what I'm going to write, formatted string, the original list is, which is new list of numbers, and the sorted list is new sorted list of numbers. And I run it. So here you can see the original list is as it is. Okay, but is anyhow in the sorted order. Let me change the order. Let me write 100, 20, 300, and 4. So yes, this is the original list, and this is the list in the sorted order. Even here we can also write reverse is equal to true, and it will now sort them in the descending order. So for your easiness, list in ascending order is this, and I'm just going to copy these two lines and here I write reverse is equal to true, descending order, and it's working fine. But understand the thing, the main gist is what? My original list is intact. It's not getting changed. It's not getting affected. Right? Okay. Now, okay, first complete the code. Done, friends? Okay. Now say we are going to understand list. List is a mutable. Okay. So I'm going to explain you this concept in a way. Say I'm going to create one list. The list is list 1 is equal to 1, 2, 3. And I write list 2 is equal to list 1. So this is what list 2 is referencing the list 1. List 2 is not the independent copy of list 1. It is still referencing the list 1. So you can understand it like this. In memory, say list is a reference type. object is a reference type, right? They are not the value type. So this is how happened. This is what happens here, how it works. This is say my stack, and this is, I'm just giving you some rough idea. This is say my heap. Now here I am having this list 1, and this is referencing here say 1, 2, and 3. This is what is stored. Now what we write, list 2 is equal to list 1. So this is also referencing the same one. It is not the new independent list. As a result, what happens, say I can have entire 2-hour session on discussing how it works in memory, stack, and heap. That is not the concept of our this video. So I just give you some rough idea. So now say if I write list 2, take the item at index 0, and if I assign the new value 99, and now I print list 1 and list 2. Can you tell me what would be the values of list 1? No, it's not 1, 2, 3. Now both would be 99, 2, 3. Let's check it first. Print spelling is wrong. Yes, you can see both are 99, 2, 3. Why? Because again, if you remember that diagram, this is your stack area. This is what the heap area of the memory. And what we have list 1, which is pointing to value stored here. This is list 2, that is also pointing to the same. That's what you did here in this line. So now list 2 is modifying the first element with 99. So list 2 has modified it to 99. As a result, now both are 99, 2, 3. So how we can override this problem? So I can write here, say list are mutable. So what I can do here is I can use the copy method or list slicing. So now again I write the same one, say list 1. I'm just reassigning the list with the same value for your better understanding, 1, 2, 3. And now I write list 2 is equal to list 1 dot copy. Now it is not referencing the list 1. List 2 is the new independent copy. So it's no more referencing the list 1. It's new independent list. Now if I change this to first element with 99, and if I print here list 1 and list 2, so list 1 would be 1, 2, 3, but list 2 would be 99, 2, 3. Right? List 1 is 1, 2, 3, list 2 is 99, 2, 3. Because what we did here, so again, if I go to the same diagram, this is my list 1. This is the stack and heap concept for your understanding, better understanding. I'm making it very simple. List 1, which is 1, 2, 3. Then you write list 2 is equal to list 1 dot copy. So list 2 is also now what? A new list. 1, 2, 3. It is not referencing the old list. And now I change first element in the list 2 is 99. As a result, list 1 is 1, 2, 3, list 2 is 99, 2, 3. Correct. Now we try to add elements in the list. So to add the item in the list, we have 3 methods. Append. What is append? It adds the item at the end of the list. We have insert. Insert method is having what? Insert method is having index and value. So here insert method adds the item at the given index. And third one is extend. Extend populates a list with other list or tuple or dictionary like this. Right. So what I'm going to do here is let me create the new list, say new food list. In this list, I am having one item called burger. And if I print it, new food list, it will print what? It will print burger here. It prints burger. Now I say take this new food list dot append say pizza. And now if I print new food list, so the output would be burger and pizza. So new item is appended. It is added at the end of the list. See, burger and pizza. And then we have insert method, which adds item at the given index. So I write new food list is equal to, say at index 0, I want to add a chocolate. So it will add chocolate at index 0. So now it would be chocolate, burger, and pizza. We add the item at given index. It's the item at given index. And if I print new food list, it's like not my bad, new food list dot append. Typo error. Yeah. So I use append method and insert method. I use insert method and I say insert chocolate at index 0. So now it will be chocolate, burger, and pizza. This is what chocolate, burger, and pizza. Initially it was burger, we appended pizza, and now we have inserted chocolate at index 0. Now one thing is, if you try to insert item at non-existent index, it works like an append. So what happens? I tell you. Say I try to add item at index 200, which does not exist here. So what happens? It will simply append the item, right? So let me write it down and say new food list dot insert item milk at index 0. And if I print here, So you can see now it's working like an append because we do not have any item at index 100. It's simply working like an append. Correct? Yeah. Just complete the code. I'm giving you a minute to complete it. Done, right? Fine. Now we see one more approach here, which is extend method, right? So with the help of extend method, what it does, it populates the list with another list. So I'm just going to create the new list. Say first list is equal to, I just write laptop and mobile. And I create second list is equal to say tablets and watches. Now I say first list dot extend with second list. So what it does, it will take each and every element of the second list and populate them in the first list. What it does, it takes each and every element of the second list and populate them in the first list. So now if I print the first list is, I'm going to write formatted string and the second list is the second list, and I'm going to run it. So this time you can see all elements of the second list are appended in the first list. In a way, first list is extended by the second list. Second list is as it is. Now, as I told you, we can use extend method with tuple, set, and list. So we don't know tuple, I know, but just here, if the second list instead of this list is a tuple or dictionary, we can still use them, right? And the last method here we discuss is the reverse method. What it does, it reverses the list elements. So here, what I'm going to do is, I'm going to create the new list, say, original list is equal to A, B, and pizza. So I print original list. And now I can do original list dot reverse. Now if I print original list, and I'm just going to write here reversed list. So you can see reverse list is pizza BNA. Original list is A, B, and pizza. Reverse list is pizza BNA. One more thing to keep in mind, like, when we work with these sort functions, here, we can sort the list element. Even if list is of type string, we can still sort, but we cannot sort an heterogeneous list. If in list I have 3 elements, one is integer and 2 elements are string, I cannot sort them, right? If it is the whole integer list, I can sort. If it is a whole string list, I can sort, but I cannot sort an heterogeneous list, right? Apart from these methods, we have many methods available in the list, but I hope it gives you clarity. Later on, when we create a mini project and when we work with advanced Python as well as pandas and numpy, you are going to utilize all those things, right, in a project. But I hope it gives you clarity in basic Python picture, right? So here we understand list, which is a mutable collection. Each item is separated by comma. Item has an index starting with 0. To create the list, we use the square bracket. Don't miss out the next video, which is on second data collection, which is tuple. So we are going to discuss tuple next.